Thank you to all for being here. Thanks to Lucas. He's the MVP of this night, of this event. He was the brains, so thank you very much. And I would also like to thank my cat, Whiskey, for keeping me calm in time of need, and yeah, helping me out a bit with some code reviews from time to time. So we don't have much time, so the summary of our talk today will be a super quick intro about Cult of Coders, what we do. I won't bore you too much with that. How do we solve relational problems in MongoDB? How do we solve the Meteor scalability problem on Reactivity? Why Apollo is a new hope for us all? And some ending notes where we draw some conclusions. Okay, so this is where we are from the Eastern Europe, the center of the world, of this flat world. And yeah, this red dot represents a lot of love for Meteor, so from that place there's a lot of love. Basically, we discovered Meteor in 2005, short after we've opened the doors to our business. We are like super niche, we work only with Meteor and React. We recently started to embrace Apollo, and we love open source. Okay, so that's about it. Let's dig into the fun stuff. So when we started in 2015, our first project was a sort of mini social network. So we were trying to build a social network on NoSQL. So clearly we hit this problem on how do we fetch related data. So in order to achieve that goal, we had to rely on publish composite because that's what was going on right there. Then it was hard to switch between having a reactive query and a non-reactive one. We had a lot of performance problems, and you know that thinking in NoSQL requires new paradigms. But sometimes you can just do it, so it's a no-go. So what do? We introduced Grapher, which is a Meteor package that solves the relational issues that we had. It's super performant and lets you think naturally about your data models. And of course, it's based on Meteor and MongoDB. Okay, so let's try to see what this package really does. Imagine what we have here is like a request. So it feels natural. I want the list of the invoices, and from the invoices, I just want the total, the status, and then I want some information about the client, like his first name and last name. So if I'm executing such a query, I would expect a result like this one, right? I have an array with only the information I've requested. Yeah, Lucas and Ben pay their invoices. And, and so it feels natural, right? So this way of doing things was actually inspired from GraphQL. And I thought, let's bring this to Meteor and MongoDB. Okay, so in order to understand how Grapher works, let's see how we can connect relations to each other. So we don't have like one-to-one, many-to-one, we just call it one. So for example, you want to store user ID at a comment level or at a post level. It's just a string, right? Because in Meteor, IDs are strings. But you can also store an array of these strings. Like for example, a post has some tags that are stored in other collection. Okay, things get a little bit more advanced when we introduce this concept of a meta link. One meta is basically, instead of having a string, now it's an object, and it relates to the key of ID. And the advantage here is that you can also add additional fields to this relationship, which basically describe the relationship. As we see below, like the many meta, we have groups, the groups that a user is in, and maybe I can store here like the role, like when he was added to that group, and so on. Okay, now how does this actually translate to code? Well, basically we have our standard Mongo collections, and on invoices I'm adding a link to a client. Where am I reading this relational data from? From client ID. It's of type 1, and the collection is Meteor users. Yes, Meteor users is a Mongo collection with some sugars in it. So then I have an items, I store it in items ID, the type is many, the collection is invoice items. Okay, now we need to introduce another concept here. We have these direct links, but we also have inverse links. Like, for example, if I would like to query in a natural way the invoices of a user, I need to know how users relate to invoices. So this is why to do this, I'm adding a link, and then I'm basically saying it's inversed by the client, which basically will try to look all the invoices with my client ID. Okay. Yeah, basically it will allow me to query things like we see here. Okay, how do we actually query? So in order to create such a query with related data, all we have to do is apply create query on a collection and just fetch it. That's it. Now, this works server side. But before we actually dive into a real example how it blends with the client, let's understand another concept of Grapher, which is deep filtering. We have this special type of fields, which they're not necessarily fields, right? They are a sort of special way to describe a request. And we can put like the filters and options, the standard ones from Mongo collection find, at every collection node level. Like, for example, here I have it at invoices level, but I can also specify filters and options for items. So they can be specified at any level. And now let's learn another concept. We also can have like a filter function which accepts parameters, because most of the times you want your query to be modular and you want it to behave based on certain parameters. You don't necessarily need to think about the logic of actually filtering the database. You just want it to give like a natural parameter and let the filter function do that bridging for you. So basically here we have a query, and what you notice different is that we give it a string as a name. So if we give it a string, if we give it a name, then we can expose it on the server. And this allows us to do the one wonderful thing about Grapher. This allows us to import this query right here, and we clone it, because we don't want to affect it in any way. We clone it with a new set of parameters, and now we can fetch it, right? So from the client, basically the way I fetch it here in the back scenes, we actually have a method. So this is how it's done, and it also works with promises built in. Now, the interesting part is that I have the same query, it's exposed the same way, I can also use it reactively. So essentially there is no real difference in here how we use the query, whether we want it reactive or not. It's the same query, I don't have to change my code at all. This makes it possible that I can clone my query, I can subscribe to it, and basically in the back, since we're using publish composite, for those that know, we are using publish composite, but everything is abstracted to this query. It makes it so easy for you. Like, for example, to have a reactive query in React, this is what you need to do. With query that returns the query, you want it reactive or not, and the presentational component that accepts its loading, error, and data. Okay. And of course, if you want a reactive query to work, you have, if you remember, those add links at the collection level need to be loaded on the client as well. Good. Now, another feature of Grapher is reducers. For example, we may want to, combine some data, or we may want to communicate to some external data sources. Basically, creating a reducer is like this. We specify a name, the dependency, and a reduce function. This makes it possible so we can query things like this, right? So I can, in the back, since Grapher expands the graph, then compacts it, cleans up, does some garbage collection at the end, so you only get the data that you request. Good. There is also a concept of denormalization, like if I have a link and I can get some information of that link inside my artworks collection, for example here. What we basically mean is that from my owner, I want to store at artwork level the avatar path and the name. This lets me, first I need to migrate it if I already have existing data, but then if I do a query like this, then Grapher will be smart enough to know to read from the cache and retrieve it all in one go. Okay, so no extra fetches happen on user collection. Now, let's get to the interesting part, which is Grapher's performance. So imagine that we have this kind of query. In order to actually fetch this data from the database, we will have to do one query for the post, and since it's filtered by ID, it will only receive one query for the tags, one query for the category, one query for the comments, and then comments length queries for each user. So if I would write like a recursive function that basically gets the data from MongoDB, this is how I would do it. And the same we have here, like I'm getting a post, their tags, their category, the author. There are a lot of queries going on. And what I'm about to show you next is how Grapher compares to actually this recursive fetching. Because Grapher has a neat way of handling this situation. And for query 1 and query 2, these are the results. So for query 1, it's like 4 times faster. And for query 2, it's 35 times faster, which is crazy. It's so fast. Now what about query 3? Because I had 3 queries here. Well, for query 3, it timed out after 120 seconds. I couldn't get a response from the server, so it's at least 200 times faster, right? Okay, but the next question is, how does this work, right? What's the magic behind it? So imagine this query right here, users, comments, and like by, let's think that it's like an array of users, right? Many people can like your comment. So what Grapher does, it fetches all the users, then it fetches all the comments for all the users, then it fetches all the liked people for all the comments. So it's 3 queries. And it knows then how to assemble the data back. So by making 3 queries instead of an unpredictable number of queries, we reduce bandwidth, we have a lot of performance, and the database is no longer stressed. And the next question is, how does it compare to SQL? So we're talking about a non-relational database. How does it compare to SQL? And prepare to be blown away. What did we use to test this? First of all, this on GitHub, you actually get the actual full test that you can run on your own. And we used SQLize, we used Join Monster that actually transforms a request into a proper MySQL request. And we used Apollo Server to link it up and make it all happen. And these are the results. It turns out for the queries that I have created, and for I've actually had to write like a front-end mini app that runs these tests a lot of times, it shows that Grapher is a little bit faster than SQL. A little bit faster. But these results are not necessarily consistent. I have seen situations that when SQL was a little bit faster. But either way, the distinction is so minimal. The fact that they are comparable in speed is great news. Great news for Meteor community. And yeah, we can now use a MongoDB as a relational database. Okay, so quick recap. We have blazing fast performance. It allows you to reason about the data relationally. The query you can have, like, in the beginning, when you discover Meteor, everything is reactive. You want that reactive. You want everything reactive, right? But then you understand that this reactivity comes with a price, and you want to reduce it in your app. Well, with Grapher, you can just switch a toggle, and that's it. You disable reactivity on certain queries. It supports reducers, the normalization, which is very good for searching, but I don't want to get into details of that, and has so many other things. Grapher has become like a huge library and has many, many nice things. Okay, now back to Eastern Europe. So we solved this problem with relational stuff, but then there was this pink elephant in the room, right? Okay, I'm talking, of course, about the Meteor having scaling issues, right? I was reading everywhere, can I scale my Meteor sucks, Meteor. I was reading this and I thought something so elegant, something so beautiful, it must be solved. So I want to understand what was going on. So how does Meteor reactivity works? Well, you do a publish and you return a cursor. Of course, the cursor you return can be more complex, can be filtered, can have sort limits and so on. And on the client, you subscribe to this publication, And then basically, I don't want to get into the details of this, but you can detect these changes on the client side that happen from the server. Basically, the server is sending you events. So the problem with this whole thing is MongoDB Oplog. What happens is that every change that happens into the database is sent to all your Meteor instances, as if your Meteor instances were a replica set of that Mongo collection. So it's quite an ingenious way, but scales up to a certain point, and that is the point of no return, which means your app is so chatty that Meteor instances will only spend time processing the incoming events from MongoDB, and they get denial of service, and yeah, things are not looking good. So we have this problem that Meteor sends a lot of data to our instances. How do we solve it? Well, first of all, how do we measure if we solve it? What would mean a good solution? Because Mongo sends data that is unnecessary. It sends events that the instance may not need. So to solve this, well, basically, I've asked the question on Meteor forum, right? Why can't we use Redis? Why can't we use certain channels? So I wanted to get the vibe of the community from this. And it sparked quite a reaction, becoming quite a popular post on Meteor forums. But the essential thing about it was the fact that it sparked hope. Hope that Meteor's reactivity can scale and not blow up at some point in the future. So to understand the solution, let's talk a little bit about PubSub. In PubSub, we have publishers and subscribers, and we have this service in the middle that simply talks to the subscribers what information the publishers have published to a certain topic. So if I subscribe to Meteor Night newsletter, right? I'm subscribing to a topic, and Lucas is sending an email there. I receive that email. So that's a simple way to think about this. Now, how do we bring this with the reactivity thingy? Well, when my instance is performing an operation, I'm no longer listening to the Oplog. I'm making the operation to MongoDB. Then after that operation has been done, I'm sending it to Redis, and Redis sends it out to the other channel. So the first approach was, okay, so if I'm doing a modification on users collection, then I'm sending this info on users channel. So other instances, my subscribers, listen to that users channel because they have an active publication there. And yeah, they process the diff and send it out to the client. Okay, but this is not enough, because if we have subscription by ID, like something like this, and I update something, I don't want to listen to the full collection. So this is why when I'm updating something, Redis Oplog also pushes to this channel, like users and the ID of the user. And when I'm subscribing here by ID, it only listens to this channel. So every change that is pushed in there is sent, my publication by ID will only receive changes only to my user, making things so efficient. And basically, this means that you have native performance. Native performance means that if you roll out your own Express server with Redis and try to do this and then think about a lot of problems like race conditions and so on, you will end up with a solution that is comparable in speed to this one. So if you subscribe by ID, you can scale infinitely. I guarantee you this. Okay, now there's another problem, the batch updates. So a lot of people were complaining that doing a lot of removes were flooding the instances, increasing to CPU spikes. This is solved by offering the option to not push this change to Redis. So this basically solves it. Now, the next problem is the chat problem, because there we cannot listen by ID, but we usually group messages by a thread, right? By a conversation ID. They are in a group. So what if when we subscribe to something, we sort of namespace it? So instead of listening to the channel messages, I'm listening to this channel. And when I'm inserting something like a message, I'm also specifying the namespace I want it to be in. This means that my publication will only receive events in this scenario, in this channel, on this thread, making things more and more efficient. Okay, all is good in theory. We have super efficient subscription by IDs. We have namespace. We have Redis. No more CPU spikes. What's the reality of this? So this is the reality. The guys from Classcraft basically reduced their whole infrastructure by a third. The Classroom app reduced their infrastructure by 5. Why? Well, from Classroom app, I've actually talked with Ramez. He's a very good friend. The advantage that they had was that most of their subscriptions were by ID. So just by adding Redis Oplog, they actually had so much advantage out of this. So if you have subscriptions by ID, you can scale a lot. And since recently, in hive.com, Redis Oplog has been added, and the initial metrics look quite okay. I don't want to get like into the details, but this is something like that I basically already know. CPU drops, the Mongo instance is less stressed, everyone is happy. You can also use, like with Redis Oplog, you can use like pure Redis without even touching the database. You can listen to events on a certain channel and emit events to a certain channel. And this stuff can also reach the client using a similar concept as the subscribe on the client, but this time we do then subscribe. Okay, what about this? Redis Oplog and SQL. So Redis Oplog is not necessarily tied to MongoDB, it just happens to be a MongoDB. This database driver can be abstracted, and it's realistic to have like reactive MySQL in Meteor. Currently, it's not implemented. It's just a very plausible thing that can be done with it. Okay, backwards compatibility. This is like the crown jewel of Redis Oplog. All you have to do is just add it. You just add the package. You configure your Redis server. That's it. That's all you have to do. You don't have to change your code at all. And you already have a lot of performance benefits. Of course, the most performance benefits you will get from fine-tuning it, like providing namespaces and so on. Okay. Now what about this one? This one is a little bit scary to understand. Basically, someone from the community, Ben Weissman, created an application in Go which tells the Oplog, like gets all the information, all the change requests from the database, and then pushes them to Redis. And you might ask yourself, wait, isn't this like this? Why would I do this? Well, in their infrastructure, they have a lot of sources written in lots of many different languages that actually write to the database directly. And they need reactivity. With Redis Oplog, you actually have to make that push to Redis in order to trigger reactivity. So because they now listen to Oplog directly in a Golang script and then push to Redis, you don't even have to push to Redis anymore. Just do your write and that's it. So this is how they solve this problem. Okay, so quick recap. You now have control of the reactivity. You have a lot of performance. You can create large scalable apps, saves time and money for your company, and it's fully backwards compatible. I initially suggest that you start without it. MongoDB Oplog can scale quite well up to a certain point. So keep that in mind. What's next? Well, after we solved the relational issues and the issues that we had with scalability, we wanted to bring a set of standards to Meteor. We wanted to have like, I've seen so many Meteor apps, everyone is different. Because Meteor, being so flexible, allows us to do almost anything with it. So we wanted to have that. We wanted to have auto-documented API and have Grapher available on React Native. We realized that we're slowly reinventing Apollo. So we hopped on board to Apollo. So what is Apollo? In short, is a way to use APIs in such a beautiful manner. And I'm going to show you real soon. I will give you like a very short crash course on Apollo. So we have the type systems of Apollo. Like, for example, I have type user, type comment, but I don't interact necessarily with these types. What I interact with is with query and with mutation. So a query is like, I want to fetch data. A mutation is, I'm changing the state of something on the server. But I can also fetch data through a mutation. So there isn't a big distinction between them. They're both types. But they are defined like in the same way. So for comments, because I have these brackets right here, it means I'm returning an array of comments. For user, I'm just returning a user. Now I also have mutation, where I can store last activity and this returns a string. But I can also have parameters to these mutations, and for example, comment update returns a comment. So this is just me defining the API. Well, if I do this, how do I talk with this API? Well, we talk through GraphQL queries, which look exactly like this. Like, I want the comments, which I have here. Then I want the text, user, and name. Then I can also have a mutation, and look here, like in the last mutation, comment update, I can, because this returns a comment, after I do that mutation, I can also query that comment it returns. So it's kind of a neat way to do this. But these types do not contain logic. Logic is contained in resolvers. So for me to actually implement, to fetch the comments, I would actually have to write a function and just return the array of comments in that function. The same with update. I just need to update it. And because comment update needed to return a comment, here it's not, but GraphQL would complain. Now, we can have resolvers like at query and mutation level, but also at type level. Query and mutation are types. User and comment are types. You can have resolvers like this, like for example, you want the user of a comment, and the arguments are like the root, the args that I received in the query, and the context. And the context is like an object that you, with Apollo, you can make it however you wish. So basically this would allow us, if we add these resolvers, it would allow us to do something like comments, user, and full name. Okay, another problem that we also solved in this adventure was the ability to actually load this, but I'm going to skip this part. You can check that out. So we wanted a way to use these super nice tools into Meteor. But when I'm talking about the integration, I'm talking about just adding a package and that's it. So this is what we did. We've created Cult of Coders Apollo. You can get started with Apollo and like you add one package, add some NPM files, and that's it. You have support for WebSockets, Meteor account system. You have support for authentication in HTTP WebSockets, but also in GraphQL. You benefit of JSON and date scalars, which do not come with the default Apollo, and you can integrate engine in one line. Engine is like the Kadira of Apollo. You can view it like that. So we wanted to use Grapher and Redis Oplog in this. We had to. They were very good technologies, right? So we began with Grapher. The first thing, because the query, if we look a little bit back, like the query is kind of similar to Grapher. Okay, Grapher is kind of similar to this, but it's quite easy to transform. It should be quite easy to transform this into a Grapher query, right? So this is what the function AST to query does. Basically, as a fourth argument in a resolver, we get the AST, which is the abstract source tree, which is basically that query, but in object-oriented way, right? So it's basically how GraphQL transforms that nice-looking query. And the next thing that we solved is, hey, I want a quick way to just prototype my database so I can actually have collections that are only in types, and I can also perform those linking in the types. Now, the next question is, how do we bring it to life, right? How do we make it reactive? How do we use Meteor Live System for it? Well, we've created this Apollo Live Server NPM package, which basically means that in your subscription, which respects like the GraphQL subscription standards, you can return an async iterator of your cursor. And that's all you have to do. You now benefit of the full reactivity of Meteor inside your Apollo server. And this means that you would also benefit from Redis Oplog, because this uses observed changes, and Redis Oplog hooks into those observed changes, and you can now have like an Apollo that is reactive and it's super scalable. How good does that sound? Well, sounds very good, and we're super excited about all of this. Now, how do we actually use it on the front end, right? I mean, it's easy on the back end, but it should be easy on the front end as well. So we only did this currently for React, but other front-end frameworks can follow the same patterns. So basically, we have this distinction. We have a query and a subscription, which is something we don't have in Meteor. Like in Meteor, to fetch the data, we just have a subscription. But here, we also have a query, and I will explain the advantage of that. And then I have like this reactive query in which I specify the query, the subscription, and that's it. That's all I have to do to have that reactivity inside Apollo. Well, why do we have a query and a subscription? First of all, is because it gives you much more control. Like, for example, your query may get post with author and comment and so on. But when you subscribe to something, it's far more performant to subscribe on just one collection. So the advantage here is that you can detect when something was added and inject the related data into it. So again, it's not that easy as it is with Meteor, I agree, but this is evolving. It will become more intuitive in time, but still it gives you this fine-grained control, which allows you to have like super scalability and predictability. Some other great Meteor packages are DDP Apollo and Meteor GraphQL. DDP Apollo is perfect for slowly migrating to Apollo if you have an existing Meteor app. It's not compatible with Cult of Coders Apollo, but it's not a problem, because essentially what Cult of Coders Apollo is just bringing stuff together and stitching them. I mean, you don't have a dependency on that package. It's just you have a Meteor server and you just install Apollo in a few seconds, and that's it. This was my vision. I want to get started with Apollo in a few seconds. Okay, and Meteor GraphQL, which allows us to actually import these GQL files. So, quick recap. Meteor and Apollo work so well together, and I think they are like the most futuristic framework out there. You can set up Apollo in a few seconds. You can have super fast prototyping. You can use Grapher inside Apollo to have that SQL comparable performance. You can use Redis Oplog. You can use Meteor account system, and you can incrementally adopt it. So it's clear that things become so simple and so elegant, and this brings me a lot of joy, because I lost that hope 3 years ago before discovering Meteor. I was in the PHP world, and Meteor was like a fresh of breath air. So right now the vision is complete. We have Apollo, Redis Oplog, and Grapher, and together they form the arguments for Meteor. Some final notes. Well, in these final notes, I want to show you like how versatile Meteor really is. For example, for our website, we actually used WordPress. Wait a minute. Wait a minute. You betrayed us. No, WordPress is so good on resource management, on content management. There we store like the jobs, the blog posts, the open position, and so on. But the website is actually with Meteor and React and server-rendered React, and works so snappy and just calls the WordPress API. It makes things so simple and so beautiful. We also created a package called Cult of Coders Fusion, which allows you to have like a static not static website, but a site that doesn't have WebSockets enabled. And but you can also use method calls, because it makes those calls talk through HTTP with Meteor, and it also supports authentication in it. Of course, for those that don't know, Meteor works with TypeScript, which is beautiful, works with any kind of framework, and works with any database that has no drivers, of course, preferably. So I would advise everyone to start using Meteor forums more often, because the community is strong and there are a lot of well-maintained packages. You can build rapid prototypes. You can deploy in auto-scaling environments with ease. You benefit of reactivity that scales. But the journey doesn't end, because there is still one final problem. And that problem is, how do I build complex data grids in minutes? We don't have Eden from Qualia that Lucas just showed us earlier. How do we do that? And how do we do it in such a way that we have a self-documented code and any component can be hacked and customized? So this was a problem that I've been thinking about for over a year. And one night, basically the story is at 3 a.m. I woke up, I had the idea, went to a computer, wrote it down real quick. And I'm pleased to say that it's a working prototype currently. And the first place we are going to announce it is on Meteor forums. So this should be another incentive for you to visit Meteor forums more often. So that's about it. Thank you very much for your attention. I hope you enjoyed everything that I've presented.